Hello, everyone. Today we will learn about derivative block and its definition, and how and when to use it in Simulink. Let's start with understanding the concept. So I'll open the help for derivative block in Simulink and check the definition. So the derivative block approximates the derivative of the input signal u with respect to the simulation time t. You obtain the approximation of du by dt by computing a numerical difference delta u by delta t, where delta u is the change in the input value and delta t is the change since the previous simulation time step. The block accepts one input and generates one output. The initial output for the block is 0 by default. So now back to MATLAB window. I am using MATLAB 2018A version. And now I will open the untitled Simulink block. So we open the untitled Simulink block, where I will use the derivative block and show you the different input conditions and output conditions. Actually, we will check the behavior of block here. Now, let's first check the location of the derivative block in the Simulink library browser. So I've opened a Simulink library browser. Now if I go in continuous here, you can see the derivative block and integrator block. In derivative, if I go for help, then the same dialog block will open which we have seen before. And let's add this block to our model. So I'll say add to the model. Okay. Now this block is added. Let's zoom in a little. I will keep this here. I will apply a sine wave at the input. So sine wave, I'll just type in sine wave. Now, I have this sine input. I will connect this to the input of my derivative block. Mathematically we know that if sine is the input then derivative of sine is cosine. So let's add a scope block and check the same with two inputs. I'll give the input signal sine as well as the output of the derivative. Okay. I am keeping the solver setting as variable. I'll simulate this model. I have simulated it for 10 seconds. It is getting simulated. Once the simulation is complete, I can open the scope and check the outputs and inputs. Double-click the scope and it has opened. So now I am seeing both simultaneously. Click View Legends and I can change this layout so that I can see the input and output separately in two windows. So as you can see, this is starting from 0. And then a sine value is between 1 and -1, and it is starting from 0. But here the peak is at 0, so it is cosine wave. Sine wave shifted by phase of 90. You can call it as cosine, and here you can see there is a rise, because we have just seen in the definition, that the initial point is 0, so it starts from 0. This was one input. Now instead of sine, I'll apply cosine wave. So if I have to apply a cosine wave, there is no directly cosine wave option. So what I will do, I will first insert the sine wave like we did before. And there is a block called cos. I will add this cos block to the input of sine. I will apply this at the input of derivative block. Now for a cosine wave. Now as per trigonometry, derivative of cosine is minus sine. So let's run the block and check the scope. So we have sine wave at the output. So a sine wave should start from upper side. First loop is up and then lower. So first is upper peak then the lower peak, but here as you can see it's inverted, which means it is minus of sine wave. So this was my derivative of cos. Now let us check derivative of a constant. I will give a constant. Let's use the default constant value 1. And see what happens. As there is no change in the waveform, the output will be 0 because the derivative usually tells us how much change is there in the input, that is delta U upon delta T. So here the input change for a constant will be same throughout, so my derivative will be 0. Let's run the model and check the scope. Double-click the scope to open. Input was 1, but my output is 0. For any constant block, even if I check for 10, it will be same. The output will always be 0. As I told you, the input here is 10, but output is still 0. So irrespective of the value of the constant, we will always get output as 0. Now we know that sine, or the derivative function, or any input which we are applying, is applied over a period of 10 here. So derivative is a time-based process. Till now we're keeping the solver setting as auto variable. Now we will go and change the solver setting. First I will select solver as fixed step, with the step size of 0.5 for an example. It is auto by default, I can change it to 0.5. OK. Now here the output is constantly 0. So instead of that I will change the input. I will just apply a sine wave, so that I can see the initial transition and check how the initial transition has an impact based on the step size. So I'll again insert a sine wave block and connect it to the input of my derivative block. And I'll run the model again with a fixed step 0.5. So here you can see there is a transition. Here it is clearly visible that the slope has increased with changed in solver settings. The slope has moved and it is like a ramp up with a slope. Now, if I go and change the step size, it should have some impact because derivative is a time-based process. So let's see how step size impacts the derivative output. The slope must be reduced. Let's check if it happens or not. Here you can observe that it has a faster rate, smooth transition. And also the slope of this ramp is less as compared to the output of previous step size. Thus smaller the step size, smoother is the transition. That was all about the derivative block. Thank you for watching.